All right, welcome to Chapter 9, Access Control Lists, or ACLs. All right, so we're going to talk about standard and extended ACLs and then how to troubleshoot some ACLs. So first, why would you need to limit your network traffic? Think about, what restrictions would I need to put on my traffic? What am I trying to prevent? What am I trying to allow? So really, when you're doing ACLs, the best thing to do is just start with a sheet of paper and kind of have a brainstorming session with your crew and say, hey, what do we need to allow? What do we need to block? And then build your ACLs from there. So we need to stop people from getting in. And that's always the first one that people think. But they never think about, we need to stop information from getting out. Email is just a text document that's sent. Any computer can be turned into an email server. There's a lot of programs that, keyloggers, that after the keylogger software gets on your PC, it then emails out from your PC the information, like this is what keys you've pressed, without going through your email server. So one ACL would be to only allow email outside the, to go out of the company only if it's from the email server, and block all other email. You may want to limit people from shopping jobs on CareerBuilder or Monster.com. You may want to keep people from wasting time on Facebook. You may want to prevent people from doing telnets to your hardware, that kind of thing. So there's a lot of different things that you want to stop in your network. And obviously, there's always the bad person. All right, so what is an ACL? An ACL is just one or more ACEs, access control entries. And each access control entry just says, allow this or deny that. So it's just a list of permit or allow statements. Allow email, deny telnet. And you can do them from many different places, like, hey, coming in, block this. Going out, block this. Hey, on R3, block access from R1. And on R1, allow access from R3. So lots of different combinations. So again, it's always best if you sit down with your group and kind of map out, what am I trying to accomplish with this ACL before you start coding the ACL. All right, and with your ACLs, TCP obviously is the most popular protocol. Most communication, in order for it to happen, the TCP three-way handshake has to happen, SYN, SYNAC, ACK, and then data is passed. So because of this, most of your ACLs will focus on the TCP protocol. So here's kind of just a map of a session. First there's a three-way handshake. So hey, I want to talk to you. Hey, sure, that's great. Let's talk. And I acknowledge that I received your packet. And then you acknowledge you've received my packet. Then we have a connection. So that's the three-way handshake. SYN, SYNAC, ACK. Then the data moves across. Hey, here's some data. Hey, acknowledged. I got your data. Send me the next set. Hey, here's your next set. That kind of stuff. And then when it's over, hey, I'm done. Hey, I'm done, and I acknowledge that you're done. Hey, great. Now I acknowledge that you're done. So that kind of stuff. So anyway, there's a three-way handshake. There's a data transfer, and then there's the termination of the session. So for a lot of things, basically you want to stop the three-way handshake from occurring. So what an ACL does is when the packet comes in, it looks at it, deciding whether it's incoming or outgoing from the interface. And then it goes through the list, and as soon as it finds one that works, it applies that. So let's say you have an ACL that has 5 entries in it. And remember, the entries are known as ACEs, access control entries. So there's 3 permits and 2 denies. So it goes through, hey, permit this, deny this, and then if the number 4 line matches, it takes action. So totally different from a routing table. Remember, your routing table, when a packet comes in, the routing table goes all the way through the routing table, through all the level 1 routes to find a match. Even if the very first route in the routing table is a perfect match, it still goes all the way through. ACL's totally different. An ACL, as it's coming through, as soon as it finds a match, it's done. So make sure that you're aware of that difference. So here's a flow chart kind of describing how it works. So, packet comes in. Hey, is it for network A or is it for network B? Oh, hey, it's for network B. All right, so it's for network B. Is it asking for port 80? Yes, then allow. If it's not asking for port 80, so it's asking for some other port, no, then, I'm sorry, if it's asking for port 80, we deny it. And if it's not asking for port 80, we allow it. So this might be something that you do on somebody on network B, you want to block their internet access because they just don't need it for their job function. And that way they're not tempted to, Facebook and Career Builder. So again, goes through the packet. Oh, it's for network B. Is it for port 80? Yes, block their access. If not, then allow their access. They may have to do some other function on the internet, like FTP or something. All right, so on your ACLs, they always end with what they call the implicit deny. So you have to have at least one permit statement in your ACL. So in other words, if I make an ACL, hey, I want to make ACL 1, and I say deny this, and then that's it. So there's only one entry in the ACL. Then that ACL would block all traffic because as soon as you create an ACL, it blocks at the bottom of it. There's always this invisible deny statement that says deny everything else. So once you create an ACL, you have to be specific and you have to make sure you allow all traffic that you want to allow in the ACL. Otherwise, everything is blocked. All right. And then you can apply the ACLs inbound or outbound to the interface. Is a packet coming into the router? Then that's inbound. Is the packet going out of the router? Then that's obviously outbound. So your ACLs can be applied incoming to the router, exiting the router. And every ACL has an invisible, what they call the implicit deny at the bottom of it. So you have to have at least one allow statement, otherwise your ACL would block everything. All right, so in Cisco land, we have two types of ACLs. We have a standard ACL and we have an extended ACL. The majority of your ACLs will typically be extended. A standard ACL only blocks by the source IP address. So we do make access list space and then access list 10 and then the permit or deny statement. So permit this IP address. So it only allows a source IP address from the standard. Now extended, totally different. Extended, you can block by source or destination IP address, source or destination port number, source or destination protocol. So access list space and then the number of the access list space and then the permit or deny statement. So permit TCP protocol from this network anything equal to port 80. And you can change that up, so I can do anything equal to port 21 or I can do anything equal to FTP. And those would still work. So you can use names instead of the port numbers. All right, a standard ACL is numbered 1 through 99. And an extended ACL is numbered 100 through 199. Now, a best practice is to name the ACLs. So instead of doing, back here, access list 10, we might do access list, permit underscore PC5, something like that. And that way we know, hey, this ACL was to permit PC5 to do something. Well, or your name obviously can be bigger, permit access to FTP, that kind of stuff. So we can do named ACLs. Now remember, when we do a named ACL, the PC or the router doesn't get the number. So when you create a numbered ACL, it knows right away based on the number whether it's a standard or extended ACL. If the number is 1 through 99, it's a standard ACL. If it's 100 through 199, it's an extended ACL. But in named ACLs, it doesn't know because you're just using a name. So you also have to include the word standard or extended. So we'll talk about that in just a second. So, and then to make ACLs even more complicated, they use an inverse subnet mask, which means they use a reverse subnet mask. So if you have a /24 network that you're trying to block or deny, so the subnet mask is 255.255.255.0, with the ACL, you flip that around, and then it becomes 0.0.0.255. So you should have, at this point, you should have already had, OSPF, and so you should know what an inverted subnet mask is. Remember, you just take your regular subnet mask and you subtract it from 255.255.255.255, and then that becomes your inverted. All right, so here's some examples. Remember, with an inverted subnet mask, 0 means it has to match perfectly, and a 255 means it doesn't have to match. So here in this top example, if my wildcard subnet mask is 0000, it means everything has to match. So if it's 192.168.1.1 with a subnet mask of 0000, it means it only will accept 192.168.1.1, nothing else. Now, if my address is 192.168.1.1 and my subnet mask is 255.255.255.255, it means anything can match. Because remember, 255s in a wildcard subnet mask or an inverse subnet mask mean nothing has to match. Now, this is typically what we see in the ACLs. So 192.168.1.1, and theoretically this would have a /24 subnet mask. So instead of being 255.255.255.0, we just reverse it, 0.0.0.255. So the zeros tell you that those first three octets have to match perfectly. And the 255 over the last one says in the fourth octet any number could be there. So basically we're allowing the entire network 192.168.1.0. All right, moving on. If my subnet mask is not the standard, /8/16/24, like in this case here, I've got 192.168.16.0, but my wildcard mask is 15.255. So in this case here, let's say my subnet mask, or my IP address and subnet mask was 192.168.16.0, and my subnet mask I was using was 255.255.240.0. I just take the 240 and the 255 and subtract it from 255.255, and then I get the 15.255. And then that would block just the small network of 16 through 31. So hopefully that helps you kind of get the idea. You should have already had experience with wildcard or inverse subnet mask in the OSPF chapter. If this confuses you, come see me, or make sure you say something at the beginning of class. More than happy to go over this. And again, if you've got a question, other people in the class have the same question. It's just a matter of which one of you is going to be, have the courage to actually ask the question. All right, so again, just take 255.255.255.255 and subtract it from whatever your subnet mask is. So if my subnet mask is 255.255.255.0, the inverse becomes 0.0.0.255. If my subnet mask is 255.255.255.240, it comes out to 15. So again, easy peasy. All right, and to make life a little easier, actually depending on how you look at it, even more complicated, you can change, instead of using all zeros or all 255s, you can change them into words. Like all zeros would mean, hey, you're trying to block a specific host. Remember, if we go back to here, if I use all zeros, it means I'm specifically blocking one person, one IP address. So I'm blocking a host. So instead of doing 0.0.0.0, I can say host. And here, instead of using 255.255.255.255, because that allows anything, I can use the word any. So going back to that. So just remember, all zeros would mean one specific host, and I can instead of using that, I can just say host. And with all the 255s, it's meaning anything, so I can just use the word any. So here's an example. Access list 1, permit anything 255.255.255, so I can just say permit any. Or access list 1, permit 192.168.10.10.0.0.0.0, access list 1, permit host 192.168.10.10. All right, so some general rules. ACLs in firewalls or routers positioned between your internal network can use ACL. So really any router anywhere can use an ACL. Where we typically see the ACLs though are at your border, your perimeter. I'm trying to block traffic from coming in or going out of my network. But some companies that you go to, they may have a research and development department, and then they may have to limit traffic to that one specific area. So then you start seeing ACLs on internal routers. Remember, you can have an ACL on any router in your network. All right, so they have 3 guidelines. There's 3 Ps, for ACLs. So you should typically only have one ACL per protocol. If you got one ACL that says, hey, allow FTP, and hey, deny FTP, that kind of stuff, it gets confusing. One per direction. You need to either apply it incoming to the router or outgoing through when it's exiting the router. And then you should only have one ACL applied per interface. So, I should only have one ACL on gigabit 00. If I have any more than that, it gets confusing. It's just bad. So one per protocol, one per direction, one per interface. All right, so some best practices. Your ACL should be based on the company security policy. What are you trying to block? What are you trying to allow? That kind of thing. You should have a description of what your ACL is to do. Remember, the easiest thing to do is before you even get to the router, you should be mapping out what you want your ACL to do and then create it in a text editor or something like that. And then obviously after it's created and you paste it into the router, then you have a copy of it for your files. So if something's getting blocked or whatever, instead of having to go through the ACLs and all the stuff and access your configs, you can just pull out the file real quick and say, hey, is that an ACL issue? That kind of stuff. And then obviously you should test your ACLs. Now, depending on your company, a lot of times you can do it after hours. You apply the ACL and then have somebody go to one place and then do it. Some places have test networks where you can apply ACLs and do things that way. So again, it's whatever your network allows. But the last thing you should do is just come up with an ACL and slap it on the router in the middle of the day. Because then your phone's going to start ringing off the hook. I can't get to my website, that kind of stuff. All right, now where to place ACLs? You want to place ACLs where they have the greatest impact on efficiency. Extended ACLs should be placed closest to the source, and standard ACLs as closest to the destination. Remember, a standard ACL only blocks by the source address. So if you block the source address close to the source address, he won't be able to get to any other traffic. So with a standard ACL, you want to block him closest to the destination. So the way I've always remembered this is I always write ed diagonally, and then I put an S here and then an S here. So extended go closest to the source, and then standard go closest to the destination. If you've got some other way that works for you, that's great, but this has always worked for me. I always just remember ed diagonally, and then put my S's in, and then extended go closest to the source, standard closest to the destination. All right, so let's look at that. So I want to block all traffic from 10 to 30. So what I'm trying to do is I'm trying to block traffic from PC1 to PC3. If I put the ACL that blocks traffic, remember, a standard ACL only blocks all traffic from the source. If I put that on R1, then R1 won't be able to communicate with anybody because it's going to block his traffic. So I want to put it as closest to the destination as possible. So in this case, I can either put it inbound on R3 or outbound on R3. But if you put it inbound on R3, it would also block traffic from the 10 network to here, to the 31 network. You don't want that. So remember, closest to the source, so the destination. So you want to block it here, outgoing on R3. And that way, if PC1's going to PC4, which is allowed, he would hit the R3, and then it would go to the exit interface G1, and it'd be allowed to go through. So remember, standard goes closest to the destination. Otherwise, you'll restrict traffic that you're not trying to restrict. All right, so extended. So remember, extended ACLs go closest to the source. So in this case, in this example, we're trying to go from PC2 and block Telnet and FTP traffic to PC3. So what we want to do is we want to block it here incoming to R1 before it even gets out on our network and causes extra traffic. So if it's applied incoming on gigabit 01 and that traffic comes out, it gets checked before it gets routed. So that way, if it's FTP or Telnet, it just gets stopped right there and it doesn't interfere with anything else. If I put it outgoing here, my router would have to make a routing decision, and it might block other stuff. So in best case, you want to put it right there on incoming to R1. Remember, extended closest to the source, standard closest to the destination. All right, so now let's talk about how to create the ACLs. Remember, you just go into global mode and you just create the ACL. So access list 1, access list 100. Remember, if I number it 1 through 99, it's going to be a standard ACL that only blocks by the source. If it's 100 through 199, it's going to be an extended ACL and I can do other stuff. All right, remember, your ACL always has an invisible deny everything else on there. So these two ACLs pictured here are the exact same thing. Access list 1, permit this traffic, or permit this traffic and block everything else. Remember, these are the same because there's always an invisible deny on every ACL you create. So make sure you keep that in mind. Your ACL has to allow all traffic that you want to allow. All right, so again, it's not like the routing table. Oops, sorry about that. One of my kids walked in and I totally lost my train of thought. So back to this slide. So your the ACL does not function like a routing table. As soon as it finds a match, it acts on it. It does not read the entire thing. So in this case, when you create the ACL, if I do the deny, 10.1.0.0, and then I want to allow a specific host, this wouldn't work because as it reads the ACL, the deny would be first, and then it would act on the deny. So when you do your ACL, you have to create your ACEs, your access control entries, in order, and you typically want the allows up front. So if you want to allow one host but block everybody else, you have to allow 10.1.0.1 and then deny 10.1.0.0. Otherwise, you'll deny that host. So again, order of your entries are important. All right, so let's look at how an access control works. In this case, I'm trying to deny specific hosts or something like that. So here on my ACL, deny this host and then permit everybody else in that network. And then in this case, deny anything from 192.168, but then permit 192. So 192, I don't know, 175 would be allowed here. So again, packet comes in. Is it asking for 192.168.1.1? No. If it was, I would kill it. So if that host came in, I would deny it. And then kind of goes through the processes. Is it going for this? If it is, then deny. If it's going for this, then allow. Is it from here, then deny. That kind of stuff. And then don't forget, at the very end, there's always the implicit deny, the invisible deny statement that says, if something hasn't matched in this ACL, deny everything else. All right, so the full syntax is, access list space the access list number, and then you've got three choices: either deny, permit, or make a remark. And then the source, the wildcard subnet mask, and then the word log if you want to log. To remove an ACL, you just put no access list. So let's say I make access list 1, permit this, access list 1, deny that, access list 1, do this. And I'm like, oh crap, this is all funked up. I need to start the whole thing over. Just do no access list 1, and that would remove it. All right. When you're making your ACLs, it's standard, and especially in networking. Let's say you're with a company for 5-10 years. It's normal to make an ACL in year 2 and then have to go modify it in year 5. So it's been 3 years since you made that ACL, and you're like, why did I make this ACL? What was I trying to do with it? So that's where the remark command comes into place. So you can put sentences of information in your ACLs to tell you why you made that and what its purpose was. So we'll see an example of that in just a little bit. All right, so again, they throw this slide here, hey, if you try to create some ACLs when you're trying to put them in, if you do something wrong, it'll actually let you know. So like in this case, you're denying an entire network, and then you try to do a permit for a specific host. It says, hey, this isn't going to work because you're blocking it here. All right, once you create the ACL, you've only created an ACL. You have not turned it on. In order to turn it on, you have to go to the interface that you want to apply it to, and then you have to use the access group command. So access list creates the ACLs, but the ACLs don't do anything by themselves. They have to be applied. So then you do IP access group space 5, I want access list number 5, and then you have to give a direction, in or out. In coming to the interface or out going to the interface. So just remember, ACLs are always a two-step process. You create the ACL, and then you apply it to the interface. So in this example here, let's say I went to interface gigabit 00, enter, and then IP access group 5, out. So 2 commands at least. All right, so applying ACLs to the interface. So first, hey, I made AC access list 1. I didn't like it, so I do no access list 1. And then access list 1, deny host, blah. Then access list 1, permit everything else. So the purpose of this access list is only to block traffic from one network or from one host. Then I go to the interface, gigabit 00, and then I apply it. IP access group in. So this ACL is applied incoming to G1. So anything from 10. So anything from PC1, when it would go into this router, would be blocked. So in that way, remember, ACLs are applied on the interface. Then, if it's allowed, then the router goes through the routing table and does a route lookup. So we want to avoid that part. All right, you can also name your ACLs. So remember, when we name our ACLs, we have to put in the word extended or standard because the ACL then doesn't know because we didn't use a number. So IP access list standard, name, or IP access list extended name. And then once you put that in and hit enter, then the prompt changes to standard, ACL. And then you can either start putting your deny and permit statements in or put remarks in. And then when you apply it, IP access group to the name and then direction in and out. All right, so commenting. So here we go. So access list 1, remark, do not allow guest workstation through. And then access list 1, deny this. And then access list 1, hey, remark, allow devices from all other networks. So access list 1, permit the other network. Then go to the interface and then access group, IP access group 1, apply this outgoing to the interface. So you can see here, he puts a remark statement above everything that he does, so each line, to kind of remind himself of what each line is supposed to do. When you're first making ACLs, it's a good idea to do that. And that way when you go back through, you kind of have an idea. Otherwise, once you've done some ACLs for a while, you can just do like 4 remarks at the end. Hey, this ACL was to block this and allow that, that kind of thing. All right, so let's say you're doing a named ACL. Everything else is the same. So first you do IP access list, standard access list, and then this access list is called no access. So instead of doing IP access list 1, we're doing IP access list standard no access. Then remember, so the prompt changes. So remark, blah, and then deny host, remark, deny host, or permit any. And then we go to the interface, IP access group, the name, space, outgoing. So these 2 access lists do the exact same thing. This access list is just named 1. So the router already knows it's a standard access list. This access list here, we're going to call it no access. So we have to put the name standard in there. So I hope that kind of clears that up for you. All right, editing access lists. Oh, what a pain in the butt. Basically, what you have to do with standard access list, you have to remove and recreate. So what Cisco says is, hey, go look at the access list that you have, copy it into a text editor, make your changes, then remove the access list on the router and then paste your new access list. So I might do, show running, include access list 1, I make a copy of it, I put it into a text editor, and then I modify it the way I want to in the text editor. Then I go back to the router and remove it, and then I grab the copy from the text editor and I paste it over. That kind of thing. So there's no editing on numbered or standard numbered ACLs. All right, if you use lines, you can remove lines because everything's specifically by line. So there's line 10, line 20, that kind of thing. So then you can actually remove the numbers with, no 10. So I go into the access list, IP access list standard 1, no 10. And then I make a new 10, so 10, deny host. So this is the best way really to do your access list, especially when you first start, because you're going to make mistakes and you're going to have to renumber things. You also want to have room between lines in case later on you have to add stuff. I typically do them in multiples of 5, line 5, 10, 15, 20. In this case, they're doing 10, 20, 30, 40. So again, when you do your permit and deny statements, you just put the number of the line in front of that. And again, that way you can also order your statements. If you make the entire, let's say you got a big 10-line ACL that you just made and you're like, oh crap, I need to add something to the line 2 that I forgot. This way you can go back and say, if line 1 is 10 and line 2 is 20, you can go, hey, a new line 15, and that would pop it right in the middle and make it the second line. So numbering your lines as you put them in there will allow you to modify those. So again, when I'm trying to add a line, I just make the new line with 15, and it pops it right in there. So that's why you want to leave some space. Now, in our labs and in most networks, the ACLs are relatively small. They're only a couple lines. But imagine if you went to go work for an international company like Timken or Diebold or Time Warner Cable, how big some of their ACLs would be. So again, at that point, you'd have to have some spaces between your lines, and putting your lines in the right orders obviously would be very important. All right, to verify your ACLs, you can go to the interface and then you can check out the ACL. So if I do show IP interface, 0000, it says, hey, there's a outgoing access list number 1, and there are no incoming access lists. Or I could do show access list, and then it would show me an example of my access list. Now remember, just doing show access list just shows you the access lists that are created. Does not tell you whether they're applied or not. So you have to go to the interfaces to see where these access lists are applied. So just because somebody created an access list does not mean it's applied. And it's not unusual to go into a company that's had a router working for 10 years, and to go in there and see that there's a whole bunch of ACLs on there that are no longer used. The client they were trying to block that employee may have gone now. Different things happen, but basically what happens is somebody makes an ACL, they do something, 5 years later they don't need the ACL, so they just remove it from the interface. They don't delete the ACL. So then you go in 10 years later and there's like, hey, why are there 20 ACLs on here that aren't applied? So you get the idea. All right, these commands can also show you like the statistics. In this case, hey, deny 10. So if I do show access list, it shows, hey, there have been 10 matches for this deny. And this is very important. Remember, you want to be proactive. You don't want to wait for somebody to do something and have the security breach happen and then react. If I'm watching my stuff and I'm like, hey, for some reason this PC has tried to get out and do what he's not allowed to do 8 times. So 8 times he's been denied. Well, why is he trying to do something 8 freaking, 1 time is a mistake. 8 times is not a mistake. Somebody's trying to do something they're not allowed to be doing, and you need to be investigating that. So again, that shows. All right, and then there are some special commands in ACLs like access class. Remember, almost all ACLs are going to involve some blocking or denying or allowing telnet and SSH, because that's obviously one of the first things you want to do. You only want to allow traffic to your routers from a certain source. So there's a specific command for that, so it's access class. So access class 5, in, that kind of thing. So just make sure you remember that access class is used to filter telnet or SSH traffic. All right, so verifying, a list or to test whether your ACL is working. So I create an access control list. So I want to permit traffic from 10.0 network on port 21. I'm sorry, this is access list 21. So I want to allow traffic from 10.0, but I want to deny everything else. So then if I go to my PCs and I try to do, hey, I want to SSH into, 10.01, this guy gets a login prompt. This guy gets denied right away, and the connection is refused. So that would be another way to test your ACL. All right, moving on to extended ACLs. Remember, extended ACLs get much more complicated because we can block by the source, the destination, the protocol, the port numbers, things like that. So we can use port numbers, so anything equal to 23, anything equal to 21, anything equal to 20, or we can use names. Anything equal to telnet, anything equal to FTP, anything equal to FTP data. Remember, FTP actually uses 2 ports, 21 and 20. 21 is the control channel, 20 is the data that gets passed. So if I block 21, then it'll never establish a connection, and then data will never happen. So we typically call FTP port 21, even though it uses 20 and 21. So just make sure you remember we can use keywords or port numbers when we're doing extended ACLs. All right, so the command is, access list space the number 100 space, deny, permit, or remark space the protocol source, typically TCP, space the port, the destination, that kind of stuff. So let's look at it here. Let me go back to this one quick. This established parameter. Established means, has the traffic been established? So I may block port or FTP only from established sources. So if my PC goes into a router on port 21 and I've established the connection, it allows returning traffic from connections that have been established. So that's what established means. Allow the return traffic, from the source. All right. So again, access list 103. So 103 obviously is higher than 100, so it's going to be a standard access list. Permit the protocol TCP from network 192.168.10.0, anything equal to port 80, and then permit anything from that network, anything equal to 443, and then on a new ACL, permit anything equal to established connections. And then it goes to the interface and it applies them in and out. Now let's talk about this. So what I want to do is I want to allow from this network here, the 10.0, I want to allow them internet traffic, and then I want to allow them SSH, so 443. So I want to allow them internet SSH. So I apply that closest to the source. So I would apply that incoming to R1. And that way R1 would block here at gigabit 00 anything incoming that's not from those two ports. And that way the router is not, doing other things like, hey, allowing those all the way into the router and then making, route lookups and doing other things, wasting, CPU and memory resources when I don't need to. So I applied 301 incoming to R1. But 104 is going to allow established connections outgoing. So when S1 goes out to port 80, it allows that established traffic to come back on R1. So R1, or I'm sorry, the ACL 104 is applied outgoing back to the network. Now the reason for that is you've allowed a connection to the internet from this network here. But what happens when a packet comes in disguised as an internet packet and you don't have any web browsers open? Without any ACLs, it would be allowed through, but because you did established, the router would look and say, hey, before I pass this out on 00, are there any established, port 80 connections coming out? Well, there's none, so I would not allow another one coming into that interface. So that's what the established parameter does. It looks to say, hey, did you initiate traffic for this? If not, I'm going to block it. That way your port 80 traffic can go in and out because you've established that connection, but if some reason an FTP packet or something comes in, it would be blocked. And that way you can do whatever you want inside to do stuff, and then random spoofed packets won't be allowed in. So I hope that clears up this established parameter. If not, remember, when you come in for lab day, say something, and I'm more than happy to cover that for you. All right, let's look at another extended ACL. So access list 101, deny TCP from this network, as long as it's equal to FTP. And then deny anything equal to FTP data, and then permit any. So permit traffic on IP from any host to any destination. And then go to gigabit 01 and apply that incoming. So in this network over here, what I'm doing is I'm blocking any FTP access and then allowing everything else. So, and then I'm applying it inside so that it gets blocked, before it goes anywhere. So that, again, the router doesn't have to make any changes. So if you're trying to block one specific thing, that's how you can do it. Block the specific thing and then do a permit any to allow other traffic through there. All right, named extended ACLs. Remember, if we create a name, we have to identify whether it's going to be an extended or a standard. So IP access list extended, and then we're going to call this surfing. So we're going to allow traffic from network 10 as long as it's on port 80, and traffic from 443 SSH. And then we exit. Then we create another one, browsing, and we allow anything established, and then we go out. So now I've got two ACLs, a surfing and a browsing. And then I go to port gigabit 00. Remember, close. It's an extended, so it goes closest to the source. So I'm going to go to the very first interface from that network, and I'm going to allow surfing inbound to the router, and then allow browsing outcoming from the interface or the router, however you want to say that. So again, anything. So my PC would be allowed to go out port 80 and SSH, so I'd be allowed to go out to the internet. And then returning traffic that I created, so I initiated a session to a web server, so the web server traffic would be allowed back because of established. But if a packet came back from, an SSH server and I had not gone to that SSH server, it would be blocked because I have not established that connection first. So remember, established means I created the session. I initiated traffic going out the network, so allow the return traffic back. So it's neat that routers can look at the state of those connections and say, hey, this user has not initiated this traffic, so I'm going to block it. Because that's obviously typically what most of the exploits and hacks do. They send you packets disguised as something that you didn't request for. All right, so how do you verify those ACLs? Remember, show access list just shows you the access list that you've created. Then you have to go to the interface and you have to look for the direction that you applied those in, or whether you applied them on the interface. All right, so editing extended ACLs, remember, exact same two methods. You can use a text editor, so you can do the show ACL, copy the thing, move it over to a Word or a WordPad document, make your changes, and then go back to the router, delete the ACL, and then paste your changes to recreate the ACL. Or you can use sequence numbers when you do your permit and deny statements. All right, so some things to remember. Packets are tested inbound. If you apply an ACL to an inbound interface, it applies it before it's being routed. So an inbound packet matches an ACL with a permit, then it's sent to be routed. So if you have deny, so it's denied incoming, it would be denied before it goes through the routing process. All right, and then outbound packets are first routed, so the routing lookup is done, then they're routed. So outbound interfaces, remember, still get routed first, and then it checks the ACL. So you have to think about what you want to happen first. All right, obviously, again, if an outbound packet matches, it gets dropped. All right, so troubleshooting some common errors. So in this first example, obviously, somebody did this wrong. So, the user on PC 10 calls you and says, hey, I can't access, telnets or anything on PC 3. He's like, hey, why am I blocked? I'm only should be blocked from the server or something like that. So if you go look at the ACL, the very first line of the ACL says, deny, 192.168.10. So there's 12 matches, so he's being denied, when he gets to R3. So remember, you have to put it, in this case, it's a standard ACL, so it goes closest to the destination. So you have to go to the interface closest to the destination, not back one. Otherwise, in this case, it blocks him from anything from coming into R3 from that router. So the source that he's allowed to, let's say he's allowed to go to here, gets blocked as well. But you only wanted to block him from the server. So you should put it on gigabit 00 interface. So it should have gone outgoing on 00. All right, so in the last scenario, it was a wrong placement. We put it on an incoming interface to R3 instead of an outgoing interface. In this idea, or this example, so I can't go from 10 to 30, and I should be allowed telnet access, but the very first line denies me access. So I need to fix that. I either need to allow a specific host first and then deny the rest of the network in this example. All right, next example. So in this example, you want to allow 11 access to the 30 network, or he can telnet in to 30, but he's not supposed to be allowed. So you have to come back up here and look at the ACL. And you see that the ACL looks like it's right, but you applied it outgoing to R1. So that's not going to work. So when his traffic goes out to telnet in, it's coming into the router, so it's not checked. So then he is allowed to telnet in. So again, that's why you really got to focus on, the direction. Am I placing it correctly? That kind of stuff. All right, moving on to IP6 ACLs. They work really the same way. It's just they're not numbered. they really, an IPv6 ACL typically functions just like an IPv4 standard ACL. So we only do named it, and they're all kind of extended. So they use the traffic filter command. So IPv6 space traffic dash filter command to do the function. And then there's still that implicit deny, but there's also 2 extra permit statements that get added for ICMP. Neighbor discovery, neighbor advertisements, and neighbor discovery, neighbor solicit messages. So you'll see those added as well. And again, that's to support ARP. So again, here's your topology that we're going to be using this example. So same thing, we got to create the access list. So IPv6 space access list space the access list name, and then permit or deny, host, protocol, that kind of stuff. So in this case, so interface 00, we go to IPv6 traffic filter, and then the name, and then in. So you can kind of see they work exactly like IPv4 extended ones. So here's kind of like the whole thing laid out. So here I'm trying to deny FTP. So IPv6 access list, no FTP to client 11 or the server 11. So I create the access list, and then deny TCP any host equal, or any host coming from this, or any traffic from this network equal to FTP, and then anything from this network, anything equal to FTP data, and then permit everything else. Then I exit, and then I go to the interface, and instead of using the access group command, I use the traffic filter command. So really that's the only difference is, obviously we're using IP6 networks instead of IP4 networks in the statement, and we don't put in a subnet mask anymore, we just put in the slash notation. And then instead of IP access group command to apply it, we apply it with the traffic filter command. All right, so looking at a bigger example, so IPv6 access list restricted access. Then he does a remark, hey, I want to permit HTTP and HTTP and HTTPS. So he allows port 80, so permit TCP any host on this network, traffic anything equal to port 80, and then permit the TCP protocol, anything from a host on this network, anything equal to 443. Then deny all others, so deny everything else from them, and then permit this, permit that. So he makes the access list first. Then he goes to the interface, and he applies it with the traffic filter command, and then applies it to a specific direction. So again, exactly the same as IPv4, only you're using IPv6 networks and a slash for a subnet mask instead of an IP4, and you're using the traffic filter command to apply it. All right, to verify the IP6 ones, remember, show IPv6 interface will show you which access lists are applied to interface. Then if you do show access list, obviously here IPv6 shows up here, and it kind of shows up. And this is kind of different. Typically it's like show IP route and show IPv6 route. So there are 2 separate tables for IPv4 and one for IP6. But if you do show access list, it's not a separate command. It's not show IPv6 access list. If you just do show access list, it'll show you the IP4 and the IPv6 traffic list. All right, so to wrap it up, by default, a router does not filter traffic. Only he just decides, for his routing table where to route it to. So you have to have an ACL to filter that. And an ACL is a sequential list of permit and deny statements with that invisible deny everything else at the bottom. All right, and then if you want to get past that that implicit deny, you can just do a permit any. So if you only want to block, FTP, you just deny FTP and then do a permit any. And then obviously that invisible deny will be underneath permit any, and because it'll match the any first because the deny is at the bottom, it would still block only the FTP traffic and then allow everything else. All right, and then don't forget you have to apply the ACL either inbound or outbound. Standard ACLs only permit traffic from the source IP address. Extended, obviously several places, extended source destination, extended source port number, that kind of stuff. All right, and then IP access list standard name. Remember, if we're naming an access list, you got to put the word extended or standard because there's no number to identify it. You make an access list 101 and it says, oh, well, that number is 101. It's between 100 and 199, so it knows it's extended. But if you're going to give it a name, you got to put the word extended because it doesn't know. All right, remember, after you create the access list, you have to apply it with the access group command. All right, so remember 3 Ps, 1 per protocol, 1 per direction, 1 per interface. Remember to remove it, just no access list. You can also do show running or show access list to verify. Access class is that specific command for telnet and SSH. And then don't forget with IPv6, instead of using the access group command, we use the traffic filter command. But other than that, they're almost the exact same. Hooray! And that wraps up the ACL stuff. Remember, ACLs are kind of complicated. A lot of places actually have security guys that come in and write their ACLs for them because the ACL job is so, I guess, temporary is a word for it. Basically, you make your ACLs once and you're kind of done. If I want to block, once I've got my security configured as far as my ACLs goes, hey, I blocked, FTP and telnet access to my routers. Hey, I've blocked, all other protocols that I want to block. It's not very often that we're creating ACLs and doing that kind of stuff. So it's not something we do very often. When we first create the network, we might do them. When we add a new piece of the network, we might do them. But other than that, we don't really touch the ACLs a whole lot. It's just like EIGRP. Once you get it configured in your network, unless the network changes, there's really no need to go out and play with your EIGRP. So a lot of people kind of forget that stuff. So they get an expert who does ACLs every day for different companies to kind of come in and do their stuff. But again, it all depends on your network. All right, don't forget, got any questions on this? It's a tough subject. Bring them up in class, especially for the lab day. All right, guys, hope that worked for you. I'll see you in class.